Okay, here we're doing the mock for 10th grade semester final, page 2, number 3. 3 has various parts, and they're pretty much all about trig and a little bit about functions and inverse functions. So first it says, describe how the -2 and the -1 in the function below affect the graph of the v-shaped absolute value function. We know that the absolute value function basically looks like a V, usually a V with diagonal lines at 45 degrees. And when you do a multiply or subtract numbers from the basic absolute value function, what happens is a transformation on the absolute value function. The absolute value function becomes stretched or compressed in the vertical or horizontal direction. It gets translated horizontally or vertically. So if we remember right, what the effect of each of these numbers is either movement or a stretching or compressing. It turns out that the -1 here is a translation down, right? So what that does is it takes the V and it moves it down. Okay, so the -1 moves it, I'd say translates down 1 unit, okay? And the -2 is the vertical stretch or compression. And in this case, the 2 is a big number, bigger than 1, so it's going to actually stretch it, okay? So it's going to, instead of being a V like a 45-degree V, it's going to be a steeper V. And since the -2, it also flips it negative, flips it down, okay? So the -2 is going to do two things. One is it flips it down or inverts it. I'm going to say inverts it or reflects it over the x-axis, okay? And the other thing it does is it stretches it vertically by a factor of 2, okay? There's at least one other transformation that we learned, which is if you have -2x minus h, okay, this h here, it moves the vertex of the absolute value function to the right or to the left. So if h is positive, then it moves it to the right. And if h is negative, it moves it to the left. Okay, so you should know that one too. All right. 3b. Graph g of x, which is the sine of x, below. Okay, so let's do that. So if you remember, let's mark that this line here is 1 and this is -1. And then I'm going to graph the function sine of x. Okay? The basic function sine of x completes one cycle between 0 and 360. So it goes from 0 to 1 to 0 to -1 and to 0. If you remember, the sine of 0 is 0. So if the sine of 0 is 0, then the graph of sine must start at 0, 0, which it does. Okay, so basically this is the basic sine function. It looks like that. Okay, now it says with a different color pen, and this time I'm going to choose green. With a different color pen, graph the function h, which is -2 times sine x and then -1. Consider your answer from part A. Well, look at that. In part A, we did a transformation of the absolute value function, and we multiplied by -2 and we subtracted 1 the same way that the -2 inverts it and stretches it vertically by a factor of 2, and the -1 translates it down 1, the same thing is going to happen here. So we're going to take our basic sine function, which is the blue function. Now we're going to make it green, and what's going to happen is we're going to have the change caused by the multiplication of -2, and then we're going to have the change with the subtract 1. when you do these, do it in the order of PEMDAS. So first do the multiplication by -2. When you do a multiplication by -2, it's going to invert the blue function, so everything's going to become like an opposite direction of the original function, and then you're going to also multiply it by a factor of 2, so everything becomes twice as tall as it did before. It's a vertical stretch by a factor of 2. Okay? And then finally, we're going to subtract 1, so the whole function is going to be moved down 1 unit. Okay? So let me draw one final picture, and this time I'll do it in pink. Okay? The final picture I'll do it in pink. So I'm going to move the new tall function by a factor of 1 unit down. So now you can see that the center line of the function is at -1 because it was moved 1 down. And the height of the function is now twice as tall as it used to be because of the factor of 2. And it's also inverted because it's -2 instead of +2. Okay? All right, now we can label that these points here are 2, -2, and -3. Okay, number 3. Specify the domain and the range of the function h of x with correct mathematical expression. So h of x is the pink function. So I'm going to write down that the domain of the pink function of h of x is, and I'm going to write that the domain is the x the possible x values. And basically, with the sine function, unless you restrict it, the domain can be any real number. So the way we would write it is that x is an element of the real number set, or x can be any real number. Okay. What about the range? How do we write that? Well, the possible y values of h of x, which is the range, only range from the lowest value of -3 and the highest value of 1. So we are going to define the range of h of x as that y is between -3 and 1. Now, is it less than or equal to? Well, as you can see, the sine function actually touches each one of these maximum values every once in a while. So we need to put less than or equal to for both. Okay? Some people, for completeness, might want to say that, oh, y is a real number where y is between -3 and 1. Okay? But if you already say that y is between -3 and 1 in this form, you don't really need to say that y is a real number. It's already kind of understood that y is a real number because you've said that y is between two real numbers, -3 and 1. Okay. 3D. Explain why the inverse function of g of x does not exist. Okay. Remember that the function g of x is the blue function. So the blue function kind of looks like this, and it goes on forever, right? Now, the reason why the inverse function of this does not exist is, remember that one of the ways that you can find the inverse function is you could take this function and you could reflect it about a certain line, which is the y equals x line. If you reflect this blue function about this red line, then you get a new function. Let's call it this brown function. And it's going to look kind of like this. Okay? It's going to look kind of like this. Okay? And the problem with this new function is that it doesn't satisfy the definition of a function, which is a function cannot have two different y values for one x value. And the way you can test that easily on a graph is to do what they call the vertical line test. If you do the vertical line test and you draw a vertical line through your new function and it crosses your function at more than one place, that means that it has like more than one y value for one x value, and that means it is not a function. So that is why g of x does not have an inverse function, because if we reflect g of x about y equals x, we have 2 y values or more for some x's. Okay? All right. 3e, which is already page 3. If the reflection of g of x about the line y equals x is not a function, what do you call it? What we call it is a relation. Okay? When a relationship between y equals x defined by a math equation is not a function, then we say it's a relation. 3f, explain how you could modify g of x so that it would have an inverse function. Sketch your modified g of x function on the graph below. Okay, so normally what we do to make a function that doesn't have an inverse into a function that has an inverse is we make it so that it doesn't go on forever. Okay, so like the complication with the sine function is it goes on forever. So when you flip it over y equals x, when you reflect it over y equals x, you end up with a function that has an infinite number of y's for each x, and so if you do the vertical line test on it, it cuts it in a million places. So how do you avoid that? Instead of making the function go on forever, you cut it off. Okay, so I'm going to cut off this function, and instead of going from negative infinity to infinity, now my new red function is just going to go from negative 90 degrees to positive 90 degrees. And if I do that, instead of like that being that curve that goes on forever, it's just going to be part of the sine function. Looks kind of like this. It's still curved, but when you invert it, you'll see that if I invert it around the y equals x line, it's going to kind of, I don't know, it'll kind of look like this or something like that. You can see that it does not repeat y's for each x anymore, right? Just from reducing the size of the red function, the inverse function, the green function, is now fine. Okay? All right. So state the name of the test you can use to find out if a graph is a function and explain how it works. Okay, so the name of the test is the vertical line test, right? Vertical line test. And so what you do is, how does it work? You draw a vertical line, and if it crosses a function or a graph in more than one place, then the graph is not a function. Okay? State the name of the test you can use to find out if a graph has an inverse function and explain how it works. Okay, so before you even reflect the function around y equals x, you can already tell if it's going to fail, right? What you can do is you can do what we call the horizontal line test. If we do the horizontal line test, then we'll see that like if we did a horizontal line test on the original sine function, we can already see that drawing a horizontal line is going to cross it in an infinite number of places. So if we flip it, the vertical line test is going to fail, right? So the horizontal line test, you draw a horizontal line on an original function, and if it fails, then the inverse, or I would say the reflection about y equals x will not be a function. Okay, it's going to fail the vertical line test. If the horizontal line test fails, then that means the inverse function, or the reflection, is going to fail the horizontal line test, or the vertical line test. So the horizontal line test is kind of a way to test before you do the inverse if the inverse exists. Okay? And that is it for number 3 in page 2 and 3.